afternoon. I am Krista Sampson, and this is the ADI Books Deeper Dive. We're here for middle school or space science right now, and I will be moderating this webinar, and I am here with your presenter, Vic Sampson, so I will hand it over to him.
So what we're talking about today is our middle school Earth and Space Science book. What I did is I took a quick screenshot of the investigations for that are found in the table of contents here. So you've got a bunch of ones that focus on both the solar system, weather, geology, all of those kinds of things. We also have Earth Space Science investigations in the Texas books. However, since in Texas, we teach 6th grade, 7th grade, and 8th grade, and multiple content areas in each of those grades, you won't see a book just devoted to Earth Space Science. So in 6th grade, there are 3 Earth Space Science investigations. In 7th, another 3. And then in 8th, you've got another 3 of those there. So you can kind of see where you can find those kinds of resources if you're teaching Earth Space Science. But for today, what I wanted to do is focus on one of my favorite investigations, or one of my favorite topic is just the moon and why we see the phases of the moon as we do. So that's our first investigation in the Earth Space Science book. So I thought I would go over that and take a deep dive into that of what that ends up looking like. So as all of our investigations, we always start off with a phenomenon, right? So in the book, you'll have these handouts that you can make copies of and give to students. And we kick off any of these investigations with kids watching a quick video. In this case, it is a video that using images of the moon taken from NASA. And each frame of the video is equal to 15 minutes of time. And you can see over a 24-hour, you can see over a month period, sorry, not 24-hour, but a month period, how the moon changes. Really cool to do that. So kids can write down things they notice when that happens. Then the task introduces that the moon follows a predictable pattern, right? And the way its appearance changes over time. And we call that a lunar cycle. So what they're trying to do in this investigation is not just be able to name the phases or say that there are phases of the moon, but be able to figure out why that does the moon change in a predictable pattern over time. So once that question is shared with the students, we ask them to kind of think of their initial ideas. What do you know about the moon already? Why might it look that way? And ask them to draw a model of the interactions of the Earth, Moon, and Sun to try to explain why that's going on. We then have the students share those ideas with each other, and that leads to a bunch of new questions that they have as they're become unsure about little things, or they're not quite how to explain the overall phenomenon, but it's a great starting point. When you purchase a book, it also comes with a book code that allows you to access all the investigations in the book in our Learning Hub. And what's really nice about that is when you add these investigations to your library in the Learning Hub, you automatically have access to downloadable handouts, so you can download them in color instead of printing them out. But you also have access to what we call a presentation mode, which has the same content that the handouts do, but it allows you to present it on a screen. And it also includes all of your videos, such as the one I showed you here. So let me show you what this video looks like for this investigation about the moon phases. So I always think that's really cool to watch something like that where you can see the moon actually change over time and of over the course of a month and really see what that ends up looking like up close. So once again, in the Learning Hub, that's all embedded. It also allows you to have guidance for students. So when you're helping facilitate an investigation and move them along, you can then put this up on the screen. Notice in this one, you can actually even blow up the text to make it easier for them to read. But it's really a nice way to kind of keep everybody on the same page as you're guiding them through that, and they can provide your directions, and you don't really need to make a slide deck for anything. So pretty handy for that. Once they have gone through the task stage and they've got some new questions about what's going on with the phases of the moon, basically things they're uncertain about in their own models, we can start introducing science ideas to them. And what we do with these ideas is we align them specifically to the core ideas and cross-cutting concepts or other standards that the students are expected to know. So in this case, for this investigation, we provide them some facts about the moon, talking about things that we see. For example, the moon rises in the east and sets in the west every 24 hours. It appears to travel from east to west across the sky, just like the sun does. So they can kind of look at these ideas and use them to help figure out what's going on. Another thing we talk about then is not just the moon, but also the solar system. What else is in there? How do those objects behave? So they can use those ideas as a starting point. And then we introduce systems and system models, right? So this idea between a physical model and a conceptual model, and how you then use models to test ideas. What I often do when I'm teaching with these resources is when I first work with a class, I will just read this out loud to them and have them follow along. And then as I'm reading, I'll usually stop at a point and say, hey, well, that's kind of interesting. Maybe make a star next to that, or underline that, or highlight that. And then as we go through and get to an image, you can actually click on, well, I'll get to that in a second. But then after you're done reading all of this, then you can ask students to, in their groups, talk about what we just read together and identify any of the ideas that might be useful for helping to make sense of what's the bigger question of the investigation of what they're trying to figure out. And then you can have each group share out, you can do a common list, and then have the individual groups write down anything that they're missing. So it's a great way to kind of learn how to pull important information from a text to help figure out something. Once again, all of this is in Learning Hub, so while you can show these up there on the screen and you can read it right off the screen, the images also allow you to click on any of these images and they blow up for you. So often when you're using handouts, they don't photocopy well or anything like that. So it's really nice to be able to blow these pictures up and be able to see them in finer detail as you're moving along through these ideas. Once again, as you're presenting this, there's always these boxes that match what's on their handouts. So it's really easy for them to see this and not get lost when they're working through these investigations. It's a really nice teacher resource for you. Okay, so now they've got some ideas. They know what they're trying to figure out. So what we do then is introduce them to the materials or tools and techniques that they can use. In the Learning Hub, we have images of those set up that you can show. I usually recommend having the physical ones on a table so you can kind of hold them up and talk about this is our lamp. This is going to be our model of our moon. This is going to be our model of our Earth. That kind of stuff to get them started. Then once they know what kind of materials they have, they can go ahead and plan out their investigation. So what are you going to do with these materials? What are you going to do with a physical model? How are you going to test your physical model? What kind of observations or measurements that you're going to need to write down or keep track of? Here's a space for a picture to show what you're doing. What's nice about this is as groups come up with these ideas, they're going to be making mistakes, which is fine because they're novices, but you can go around and offer feedback and some advice as they're going through before adding your signature and having them get going. So it's a nice little check-in spot that you can let kind of kids try it out and then get some help as needed. From there, once they have a plan and you've approved it, you can go ahead and give them the equipment they're going to be using. So in this case, it'll be hands-on equipment: a lamp, a model of a moon, a model of an Earth, some stands, both that sit on tables and ones that they can hold up. And they also get a calendar that shows the phases of the moon and moonrise and moon set time, so they can use it to evaluate how well their model explains actual data. As they're working, they can start collecting ideas, right? So they can write down things or observations that they make. And then in this case, really what they're doing is developing a better model for why we see the phases of the moon. So they can actually have that space where they can draw that out and try to represent their physical model conceptually in a way that allows them to explain why we see the phases of the moon in a predictable pattern. From there, each group should have an answer to the guiding question. They should know why we see the phase of the moon in that pattern that we do. So now we want them to share out these ideas with the other groups and compare and contrast those and make them better. So what we have them do is share their ideas on a argument, which is put on these big whiteboards. And then what they can do is share these among groups, give each other feedback. To facilitate that, we actually have space in their handouts where they can, if they're traveling to another group, for example, to talk to somebody else, they can write down good ideas that they can bring back. Or if they're presenting or sharing their own argument, they can write down the advice that other people have given them about things to make it better. Here's a couple of examples of what these arguments might look like. What I'm always impressed is by the deep level of thinking that goes on in these kids as they're trying to explain these things when they're starting using these different models, and then how do they decide to present their evidence, and then how are they justifying the evidence that they have. So here's a couple pretty cool examples of how kids are thinking about making sense of the phases of the moon. To help kids out with that too, in addition to the handout and Learning Hub, we have these extra images that kind of help explain the various components for students. So if they're stuck in any way, you can show this on the board and remind them of the different pieces that they can put in their argument. Once everybody has revised their argument, then you can move on to the reflect stage and have a whole class discussion about two things. You want to talk about first the core ideas that students were using in the investigation, and also how they can engage in the practices of science in more nuanced ways over time. So to talk about the core ideas, what I recommend we do is show an image like this. This is once again found in Learning Hub. Have students in their groups talk as a team to try to answer the question about that, of how can we use what we know about the moon and the solar system to explain what's going on in this image, right? So part A, part B, part C, have them talk in their groups, and then each group let them share out, and then have other groups comment on that, or you can correct any misconceptions there. But it's a really great way to make thinking visible as part of this, and kind of wrap up everything that you've been doing conceptually. In terms of practices discussions, we include these kind of discussion prompts for that. So we always want to kind of have them focus on what went well during their investigation. So what things they do that made it scientific, right? Then things that they could have done differently if they had to do it all over again. This is where they start realizing how important certain practices of science are, and they're not worthy to skip or not think about during an investigation. And then finally, as a class, we can come up with some rules that we can always try to follow when we're doing an investigation. And that's kind of how you get good at doing science, is that you kind of have these rules that you follow of, like, I always need to have multiple measurements. I need a control group. I need these kinds of things that'll help you collect better data during your investigation to make it easier to make sense of that and figure something out. So it's a really powerful way to help kids learn from their mistakes. At the end of this stage, we really believe it's important for kids to write themselves notes to be as reflective as possible. So we include a handout that allows them to write down some important ideas that they want to remember about the content or about engaging in the practices of science. This is a great place to write down class rules that are agreed upon, because then you can come back and revisit them the next time you're about to plan an investigation. The last step of the investigation is then for individual students to share what they figured out or what they've learned. And we ask them to do that through writing for two reasons. One, writing is a thinking practice. The more that you write about something to explain, the deeper you have to think about it and the more likely you are to remember. And it also allows you to develop your literacy skills that are so important for communication in science and outside of science. So to write a report, it's relatively straightforward. It consists of three parts: an introduction, a method, and their argument. So the introduction is just what they're trying to figure out. Method is what did they do to do that? And then the argument is their answer to the guiding question and their evidence and justification of their evidence. That usually comes off the group whiteboard on that, but they now have to put it into kind of a written paragraph-based form instead of kind of pictures and chicken scratch and quick little sentences or bullet points and kind of things like that. To help them along, we supply the sentencers. You don't always have to use them, but it's a great way to do it on your first couple of investigations. After they have reports written, each student has it. You can have them do a double-blind peer review of those. The way that works, or how we would recommend it working, is if you have, say, a class of 30, I would divide your students into 10 groups of 3, right? So you've got 10 groups, your 30 kids divided into 10 groups of 3. Each group then gets one peer review guide and a report that was written by somebody outside of that group. Okay. So they, as a team, then take 15 minutes and read over the report and fill out this peer review guide. And anything you can see that it's framed around questions that the guide's asking them. And then they give a rating to that or answer those questions of no, somewhat, yes. Anything that's a no or a somewhat, they have to give feedback. If it's a yes, they think it's perfect and doesn't need to be changed. After 15 minutes, collect the draft reports and the peer review guides. Then give each group another report and another peer review guide. You can change recorders at that point if you want to. Give another 15 minutes to review that one. At the end of the 15 minutes, collect those up, give one more report written by somebody outside the group and another peer review guide, have them switch reporters and fill this out. So after 45 minutes, each group of 3 has reviewed 3 other people's reports that they did not write. All 3 of them recorded something, took turns being the recorder on the peer review guide. And then everybody in the class, all 30 students, have had their report reviewed by a team of 3. And you can get all through that in about 15 or in about 45 minutes. And it's a really great way to help kids learn content and how to write in science. Then they can do their final draft. From their final draft, you can have them do that with sentence search again. You can have them type it out. You can give them a blank piece of paper, however you want to do it. But they take all that feedback, revise the report, and then they can turn it into you along with their first draft and the filled out peer review guide. Then you as the teacher can grade it and give it a teacher score, but you're using the exact criteria that they just went through and reviewed on. So there's no surprises on how they're getting scored, and they all have a chance to fix things and make it better based on the feedback they've got. So these end up being really good by this time in this report. So everyone's grades look really good and they learn a lot. Kind of nice. Now, if you're thinking to yourself as you're going through this of like, oh, that's a lot, how I'm going to remember all of that, we really thought deeply about how to make the lesson plans for each of these investigations usable. Some lesson plans can get really too detailed, too vague, too long, too short. So we try to really find the sweet spot here. So each of the lesson plans for investigation has a quick overview. Then it talks about the stages in a graphic format. So how you can break over this investigation into multiple days by stage or activity within the stage. So it gives you a graphic organizer for that. Then it tells you all your standards is not only the science ones, but it's also language development, English language arts. This is a picture of the next generation ones, and the Texas books are TEKS and ELPS and the ELA standards for that grade level. We also include a section about things to know about this before starting the lesson. So the core idea that you're expected to learn is also usually what you're talking about in your reflective discussion, the cross-cutting concept, and the science and engineering practice. We also provide notes on what materials that you need listed by class and for each group, a picture of the setup, and explain how that works. We also make it easy for each of these investigations that you can get a kit that comes with this. So this is the kit we supply for this. This is all the stuff you would need for a class of students, for 8 groups of students in a class like that. So that works really well if you've got groups of 4 for that, because they can investigate in groups of 4 and then peer review in groups of 3. You can change groups up during this process. Super easy to do. And then finally, there by stage and activity within stage, you have a detailed lesson plan of what to do, what to give out, and what to show. So we try to divide that up so it's very easy to kind of chunk an investigation. Is like, hey, here's the first activity, here's the second activity, and it's not all together in a big one long thing. We also include teaching tips. Those are usually around management and things like that. And then ways to attend to make your class more equitable and inclusive. Those are usually ideas about how to help students that are struggling with reading, or how do you help students that are learning a new language learn science at the same time. So we provide all of these hints and tricks in there that you can use to make this go as smoothly as possible. So with that, we've got about 5 minutes or so for questions. If you haven't already, you can put them in your Q&A, or you can just raise your hand and I'll answer those for you.
Excellent. So we have a couple. And the first one comes from Tasha. And she asked, how do you handle students who disagree during the argumentation stage, but don't know how to explain why?
Oh, that's excellent. I think that's one of the hardest things that people need to learn how to do, right? So you see something and it looks wrong, but you don't really have a reason for it. So one of the nicest things about doing argumentation sessions in the middle of the instructional model instead of at the very beginning or at the very end is gives time for students to have a concrete experience of what's happening. So as they've been talking into their groups, they have used the models, they've seen pictures, they have a shared experience, and then they can pull on that shared experience as a way to say, well, that doesn't fit, or that doesn't make sense with what we did, instead of just kind of hoping that they know something about the moon. So by building all of these pieces in there, kids have more to draw from, and makes a much richer conversation.
Awesome. And Lynn says, sometimes my students just copy each other's ideas during the whiteboard stage. How do you encourage original thinking?
Ah, that's a great one. So part of the hard part about it is thinking about when you need the original thinking to happen, right? So with this kind of approach, you're bouncing between small groups, whole class, and individuals all the time. So sometimes individual thinking is really useful, or original thinking is really useful when you're brainstorming new ideas. For example, when you're doing the task stage and you're asking them to draw an initial model of what do you think is going on, that's really helpful to have a lot of diverse ideas. Then later on, when they're trying to come to consensus, the idea is that there is an answer, right? Because when we think about in science, we're coming off the explanation that best fits the evidence. And then start talking about, well, does this, not just because someone said it, but how well does this fit with the evidence? And getting that to, we share this idea because we all agree that it fits with the evidence. And then when you get to the original or the writing of the reports, kids can be encouraged to make modifications to fit things based on their ideas. And it's not just a copy of that. It's your chance to also say what you're saying, or what you're saying, put your own spin on those things. So by bouncing between those different modalities, it helps a lot.
Excellent. And I think that's it for questions. So if you want to go ahead and finish it up.
Fantastic. Okay, so today, in a couple minutes, we're going to be diving into the high school Earth and Space Science. That'll go from 4:30 to 5 for that webinar. And then tomorrow, we're going to look at biology from 4 to 4:30, chemistry from 4:30 to 5, high school physics on the following day, which would be Wednesday, 4 to 4:30. And then we're going to dive into the integrated physical science for Texas, because that's a unique class that we thought we would go over. That's at 4:30 to 5 on Wednesday as well. So hopefully you can join us.
All right. Thanks so much, y'all. Have a great afternoon.